Well, I think we will start. I mean, the numbers are slowly creeping up. We've now got 62 people logged on, which is very good news indeed. And I'm delighted to say hello and welcome, and particularly to Dr. Ken Smith. And we look forward very much to his talk. Those of you who are here for Alec Lee's talk know we've already had a little venture into the world of the dynamics affecting the woodpeckers, and Robert will now take over and introduce Ken Smith. Robert, over to you, please. Thank you.
Thank you, Chris. Well, I'm very happy this evening to introduce Dr. Ken Smith to speak on woodpeckers. For a long time now, I've tended to think of Ken as Mr. Woodpecker, although this perhaps is a little bit unfair, seeing he's also worked on many other things to do with ornithology during his career. For nearly 30 years, he was in the Rspb, working on a lot of conservation initiatives on a wide range of species and habitats. And it was on one of these in the 1980s, a survey on woodland birds, that he first got really interested, seemingly, in woodpeckers. And ever since then, he has probably contributed more to our knowledge of British woodpeckers than any other individual, along with his wife Linda, with whom he has published much of his work. He set up a site, the Woodpecker Network, online for promoting the study of woodpeckers, and has also spent a huge amount of time contributing to the avifaunal studies in the counties in which he's lived. For many years in Hertfordshire, and more recently, when he's moved to the Sussex-Hampshire border, in those counties as well. Without more ado, I will hand over to Ken Smith to tell us what has been happening to British woodpeckers. Ken?
Right, we're off, are we? Well, good evening, everybody. It's a great pleasure to speak to you. Can you hear? Somebody say whether this is coming through okay.
It's coming through.
Right, brilliant. So as Robert says, I've worked on woodpeckers for quite a long time. Most of the time, it's actually been a spare time activity, but since I've retired, it's kind of taken over a bit more again. I've actually been studying the woodpeckers for nearly 40 years. And in recent years, with my wife Linda, we've set up Woodpecker Network to promote the study of woodpeckers in general, and Lesser Spotted Woodpecker in particular. So this evening, I want to talk about two of our British species, the Lesser Spot and Great Spot. To really discuss what's been driving the population changes of these two species. So it's an amazing species pair, really. So the Great Spotted Woodpecker there on the right is the big beefy one, and the populations of that species have been going up enormously, whereas the Lesser Spotted Woodpecker on the left there, only about sparrow size, really very small woodpecker, has been going down, and it's currently red listed in every other list you could think of. So it really is doing badly. And there have been suggestions that these two trends are linked, that the increase in the Great Spotted Woodpecker is what's driving the Lesser Spotted Woodpecker. And so that's what I want to talk about this evening, really, to go through some of the things we've done and test whether that's actually the case, and that's what's been going on. You'll see on the bottom of the slides is often names and dates and references. So most of the material I'm going to talk about has actually been published. Not all of it. I'm not that good at publishing, so there's lots of things that haven't been published that should be, but most of the stuff this evening has been published. And if anybody wants to see copies of the papers, they could contact us on our website, which will come up at the end, and we can provide them. Okay, let's get into this. The Great Spotted Woodpecker then, the starling sized bird, and these are the data from the BTO about the distribution and trends in population for the species. So you can see it's more or less ubiquitous now in England, Wales and Scotland, and in the last decade and a half, has colonized Ireland all on its own. So it's done that. If you look at the map on the right, that's the abundance map from the BTO Atlas, and you can see that the main areas of high abundance are the whole of the southeast and the Welsh Marches, with a few little bits around, but that's the main places that have the high abundance of the species. And on the bottom there is actually the trend line, Common Bird Census BBS trend that the BTO published. And that's really interesting in that there was a big increase through the 70s, leveling off until the mid-90s, rapid rise again, and then looks like leveling off in the last 5 or 10 years or so. And the Great Spotted Woodpecker is one of the most rapidly increasing species in Britain. The only other things that beat it are things like little egrets and ringneck parakeets that have started from zero. But in terms of common widespread species, this is one of the big increases. Contrast that with the Lesser Spotted Woodpecker. You'll see the distribution map there on the left at the 10K square level, really looking quite thin. A lot of those dots don't represent approved breeding, and big gaps in the distribution through East Anglia and down through Middle England. But also look at the places where the species is, and that's the southeast and the Welsh Marches again, and the same sort of areas where you've got great spots. And a lot of this, I think, is down to area of woodland coverage in those counties, those areas. If you look at the change map on the right, you can see the areas where the lesser spot has disappeared in the 20 years between the two atlases. Big gaps in East Anglia, down through Oxfordshire and those sort of places. It's still retained in the southeast in the marches. Population trend data from CBC only is pretty thin. So this is the CBC trend graph for lesser spot, showing a peak in about 1980 and then a decline thereafter. And then from 2000 onwards, there are insufficient birds being counted on the standard censuses for any trend to be published. And so there hasn't been a population trend for the lesser spot since 2000. And so currently there are some trends around based on rather small sample sizes that get used in some of the DEFRA statistics, but they don't really stand up much to scrutiny. And at the moment, the main monitoring for lesser spotted woodpecker is the periodic atlases and records submitted by counties each year to the Rare Breeding Bird Panel, who collate those to produce some figures. What we did in the bottom right there is actually to see if we could get anything about what's been happening since 2000. And what Linda produced was actually a ringing index. So she actually took the ratio of the numbers of lesser spots ringed just by chance encounters of ringers, divided that by a set of woodland species, so you could normalize it for ringing effort in each year. And actually that blue line there shows quite a sensible trend for the period where there's overlap with the common bird census. But what it does show is that it looks like the population trend for lesser spot is continuing downwards, even though it's not covered by BBS anymore. Because this is pretty dodgy data, because you're talking about only a few birds ringed each year now by ringers. I find this really interesting. If you look at some of the Victorian avifaunas, and there are quite a few of them around, it seemed to be quite a popular thing to write those sort of books in that period. And they nearly all talk about the lesser spotted woodpecker being the most common woodpecker species in southern England. This is just from Butler and Frohawk, because I just happen to have a set, but you can find it all over the place. And that is quite interesting. And if I remember, I'll come back to discuss that at the end, but it is fascinating. Right, the big historical event in Britain and probably elsewhere in Northern Europe for the woodpeckers was Dutch elm disease. And what I've done here is actually pull out the population trend graphs for lesser spot and great spot and fiddle about with the scales to try and line them up in terms of years. And you can see both species, the lesser spot and great spot, increase through the 70s. And at the time, and I'm sure it's right, the explanation was Dutch elm disease. The elm trees in the landscape were dying, the bark was falling off. The vector for spreading the fungus between the elm trees was actually the elm bark beetle, which carried the fungus from tree to tree. And these trees, as they died, had a massive infestation of bark beetles. So lots of food for woodpeckers. Now, most of the things written about this say that it was either the food or availability of nest sites that helped the woodpeckers. I suspect it was the food really, rather than nest sites. After the Dutch elm period, which finished in the early 70s, the great spotted woodpecker population was fairly stable, and lesser spot dropped. And then you see this big increase of great spot since 1990, really, up to its present high numbers. So there are similarities there in terms of the effect of Dutch elm disease. And it's interesting that both species, it would seem, responded, their populations responded to this increase of resources that was around at the time. Right, the sources of information I'm going to use tonight is our studies of woodpeckers in Hertfordshire. That was from 84 onwards till we left the county in 2016. Those are mainly on great spotted woodpeckers, with some lesser spot data picked up on the way, but not as much by any means. There's an Rspb studies of lesser spotted woodpeckers from 2005 to 2009, which were actually run by Liz Sharman, supervised by me. So I've been able to call on those. I've used the BTO nest record data a lot. And then lastly, in 2015, we set up Woodpecker Network, specifically to encourage the recording of lesser spotted woodpeckers. Right, so let's start on the Hertfordshire study. So Hertfordshire is in southern England, as I'm sure most of you know. There's the map of Hertfordshire on the right, and that's where Hertfordshire is. So just on the edge of London, essentially. But Hertfordshire is actually a very well-wooded county and has some superb woods. And I, from 84 onwards, did woodpecker work in those four woods: Wormley Wood, Hodson Park, Sherrards, and Hitchwood. They're all mature oak woodlands, mainly oak hornbeam, because that's particularly in South Herts, that's the sort of woodlands you get, but all with very big trees. And the total area of the study woods was 300 hectares, or thereabouts. I set about trying to find all the woodpecker nests I could each year, and these are the number of great spot nests from 84 to 2015. And it's a remarkable increase, really. So when I started, I could maybe find a dozen nests in these woods each year. And then about 1990 time, it kicked off, just like the national trend, and increased. And then for the last few years, I was finding 60 nests a year of great spots in these woods. So that's one nest every 5 hectares, which means a great spotted woodpecker nest about every 250 meters through the woods. So it's a really big increase. And in fact, this increase is bigger than the BBS trend, which showed like a 2-fold increase. Well, this has gone up maybe a 5-fold increase in these particular woods. And so what did I find about what nests they use? Well, everybody knows, you read it in all the books, that woodpeckers nest in dead trees. If only it were that simple. It isn't at all. Here are some data comparing great spot and lesser spot nest sites published in various places and from various locations. So this, particularly the great spot data is all Hertfordshire. The lesser spot is putting together everything I could find. But there's a big contrast. So the blue bars there are the nests in dead trees, dead birch, that sort of stuff. And so for great spots, only about a third of the nests are in dead trees, and then a few of them are in dead sites on living trees. That's a big dead branch or something like that. And then the majority of great spotted woodpecker nest sites are in live trees and live sites. So they're quite capable of excavating all sorts of species that are living, oak, beech, all sorts like that. So they don't really need dead trees in which to nest. If you contrast that with the lesser spot, over 60% of the nests are in dead trees, and then the rest essentially are in dead bits on live trees. And then you've got, in this sample, I think it was 2 nests were in live sites on live trees. So essentially the lesser spot is really dependent on dead trees for its nest sites. And that's the sort of thing you'd expect for a smaller species, less capable of excavating a nest cavity in the harder trees. And the other thing I looked at in these studies was the foraging sites. So certainly early in spring, in the lead up to nesting, you can get quite good observations of the birds feeding all over the place. It's much harder in the rest of the year. And there's actually a clue in this slide really to the relative foraging sites of the 2 species. So the lesser spot there is on a live branch of very small diameter, and the great spot's on a dead bit of large diameter. And that kind of sums it up really. And so the foraging sites. So again, Hertfordshire data for great spotted woodpecker, some foraging on the ground, about half the foraging on dead sites, that's dead branches on trees, usually excavating or ripping off the bark or whatever, looking for invertebrates in the dead substrate, and then some of the foraging on live branches. Compare that with the lesser spot, which is the 2 bars on the right, Hertfordshire, and from Rspb studies that did the same sort of system, and a really big contrast. So very little of the feeding in the pre-breeding period for lesser spots is on dead sites, and virtually none on the ground. And the majority of the foraging is on living branches, off usually small diameter living branches. So again, the statement that these species need dead wood all the time has to be nuanced, I think. I used to skate over this graph a bit a few years ago, but now I've come to understand a bit what's going on. I think I'm really happy with it. These birds really are using live sites, and I'll come on later to explain why I think that is. So in the early years of the studies, all I could do really was find nests and record what was going on outside, and a few of them were accessible with a ladder and a dentist's mirror on a stick to look inside what was going on, but you really couldn't get much very systematic data on what was happening to the nest, number of eggs they laid, breeding success, etc. But the big breakthrough really was the arrival of video cameras, and I've built a really rough video nest inspection system way back when the first cameras came out. There with big batteries and wires, and anyway, it was a disaster. It never worked, but I persevered, and eventually we got the system here down at the bottom. You can see that the yellow camera there. This is made for us by a commercial company called Wildlife Windows, and essentially it's got a camera from a mobile phone. It's a really small camera with LED illumination, and you can put this probe into the woodpecker nest hole. The camera looks down and you can see the contents, and then it actually has got its own Bluetooth network, so you can log in with your iPad or a mobile phone to look at the pictures. So it's just brilliant. And the other thing that's brilliant are these things here, which are carbon fiber window cleaner poles. So they allow you to get up really high into the nest, which for lesser spots can be really important. And you see in this picture here, the camera's up there. There's me at the bottom. And over here's a picture of me inspecting a I think this was actually a great spot nest. And I'm trying to look really nonchalant because the pole goes all the way up here and the nest is right up in the top there. So if you're trying to do that with a ladder or with tree climbers, it would be a real problem. And so here's the thing, sort of pictures you get from the camera. There's the eggs in the nest. The woodpeckers usually excavate a new cavity each year, and it depends a bit on the species, but the base of the cavity is covered with wood chips, and that's really the only insulation they have. So the eggs just sit there. For great spots, it's very convenient that the young have these red tops to their heads, so you can inspect the nest close to fledging and count the number of young who are about to fledge very easily by just counting the red heads. Right, so let's have a look at some of the data here. So this is a plot from 84 to, I guess that's about 2015, of the first egg dates for the great spotted woodpeckers in the Hertfordshire woods. And surprise, surprise, they now lay their eggs earlier. And so we're all quite familiar with warmer springs and how that's all happening. And they're about 2 weeks earlier than they used to be over that whole period. And obviously there's a big range. So these are individual nests, the points, so you can see the big range. The interesting thing is that you can plot this against spring temperature. So I actually on this used April, May average temperature, but any temperature would do. But I've just used this throughout. And you can see that there's quite a sensible relationship between the data laying the first egg and how warm the spring is. So warmer springs over on the right here, they lay their eggs earlier. And there's about a week or two in that. The thing to note here is the gradient of this line. So it's about a 10-day shift for every 3-degree change in average temperature. So remember that because it comes up later. So the thing we did find very early in the study was a big interaction that went on with starlings. Now, believe it or not, starlings are well able to evict woodpeckers from their cavities and partially completed cavities. And in the mid-80s, starling numbers were still very high in the UK, and the woodlands were full of nesting starlings as well as the farmland. And the great spots really suffered from starling competition, such that the breeding success was very low. And it also meant that the lay dates were a bit later than you'd expect. So that upturn in the trend with temperature in the early years, some of that is due to starling competition, delaying the great spot nesting and making it a bit later. But that ceased within 3 or 4 years of me starting to do the work. And although there's still starlings in the landscape, they're not in the woods anymore. And so that starling competition went away by about 1990, I'd suggest. So a quick summary overall of what we found from about 1,200 great spotted woodpecker nests over those years in the Hertfordshire woods. And so the clutch size was 5.3, they pledged 3.8 young, as you can see. And the remarkable thing is the low nest failure rate. So we only recorded 48 failures in this 1,200 nests, which is hardly anything, compared with open nesting species, which are failing all the time. These birds don't fail very often. And those of you who are familiar with the Mayfield nest survival figure, that's a way of working out the overall survival of nests in an unbiased way. So it takes account of the nests you didn't know about as well as the ones you did know about. And that comes out at 0.86. So that's pretty high nest survival. And very little went wrong, really. A few times the cavities collapse because they make a poor decision about where to put it. A few get flooded. A few just disappear, possibly predation from mustelids. But at the moment, very high nest survival. Whether that sort of figure will carry on once pine martins end up in most of our woods, it'll be interesting to see, because pine martins are known to predate woodpecker nests. So let's get on to the food. So for these woodpeckers, breeding success is all about food. And you can see in this picture here is a bit of clue. For most woodland birds, they're actually feeding on defoliating caterpillars in the breeding season. I'm sure you know the story of how woodland birds time their nesting to match the peak of caterpillars. And that's what always used to happen. And so in the Hertfordshire woods, about 2000, I decided we ought to try and get some measures of what the food supply was like. And so we set about doing some monitoring of defoliating caterpillars. Now, oak trees in particular are known for getting periodically heavily defoliated by a range of caterpillars. Winter moth is the classic, but the two here, Aranis defoliaria, the mottled umber at the top, and green oak tortrix, the one at the bottom, are also involved. And in some years, the leaves on oak trees can be absolutely hammered. So we wanted to go about how we could assess this. And so we did two things. We did a defoliation index, where we essentially went round and just looked at hundreds and hundreds of oak leaves and scored them as to whether they were undamaged or totally annihilated. And from that, you could produce a quite reliable index. And the other thing we did is set up a system of these frass trays. Frass is a German word for droppings. So this is caterpillar poo, basically. You put these under the oak trees on the ground, change them every 5 or 6 days or so, and go and look in a microscope, and there you are. You'll have loads of frass in the trays. And so here's a picture. I don't know if people see on the camera, but here's some frass in a pot. That's in focus. A bit like tea leaves. I've never tried to make tea with it, but there we go. You can even tell how big the caterpillars are by the size of the lumps that come through. But essentially what we do is record it as milligrams per day, and an index for the leaf damage. And we have volunteers at 6 sites all over the country doing frass for us every year. We've now been doing it for 20 years or so. It really is very interesting and producing some really good results in terms of what's happening to climate change and response of birds. And I think Kevin Briggs, one of the volunteers, might be watching this, which is great. He does it in Lancashire. Anyway, we produced a paper on the great spot breeding success related to caterpillar frass. And this graph here is an example I've got of one of the sites, Sherrards Park Wood, showing the frass results each year from 2008 through to 16. And the solid lines here are the frass in milligrams per day, and you've got season along the bottom there. So one is April the 1st, so this is May time, end of May. And so for each year, you've got a plot of when the caterpillars were around. And then along the top here, this is when the woodpeckers laid their eggs. And then the arrow here is when they were reaching their peak food demand. So when the young are about 10 days old, this is the peak time for bringing food. And so for each year, you see the relationship between the peak food requirement and the caterpillars. There's various things to look at here. But the first is that the top graph there, the scale on the left for the frass goes up to 6 grams per day. Yeah, and as you go down through here, you'll find that actually the amount of frass has fallen to the last graph here, which is 0.04 is the peak. So the graph becomes much noisier because there's all sorts of other things going on. But essentially there's about 150-fold variation in the amount of caterpillar activity, caterpillar poo, over that 8-year period. The other thing to see is that the timing of the peak is all over the place. So the earliest is the end of April, and the latest up here is the end of May. So it's like a month shift. So that's variability of spring weather. So it might be getting warmer, but it's still variable. And the third thing to notice is that the woodpecker nesting season is variable, but nowhere near as variable as a caterpillar peak. So the woodpeckers are seem to be much more constrained about when they can time their nesting. So sometimes they can match the peak, sometimes they can't. And I think it's not only these great spots that do that, I think that would apply to other species if people did the work. And this is, I think, very interesting. So it's a feature of these this defoliation, particularly in oak woods, that it's episodic. And this was first pointed out in Chris Perrin's Tits book, way back. It was found by Charles Elton and co. soon after the war in Whiting Woods. You get some years with massive defoliation events and the leaves eaten, and the oak trees have an adaptation to grow new leaves to compensate if they lose their leaves. And the periodicity is about 12 years. And this is a plot for Sherrards Park Wood of the frass fall over the period. And in 2008, there was a peak, and 2020, it was coming up. I'm actually at this moment, the microscope's just down the desk from me, analysing the 2021 data, and there's masses of caterpillar poo again. So about every 12 years, you get these events. And the other feature is the relationship with spring temperature. And so the peak of the caterpillars moves with temperature. And here's the graph here. But if you remember the graph I showed you earlier about the change in nesting dates for the woodpeckers, that varied with temperature. But that varied about 10 days over the period. Whereas the caterpillar peak is actually varying by about 20 days. So it's no surprise that the birds can't actually stay in synchronization with the food supply with this sort of variability, because the caterpillars respond much more to spring temperatures than the birds are able to. These graphs look a bit of a mess, but I'm really proud of them actually. So this is the numbers of young fledged for nearly 700 nests in Hertfordshire against the caterpillar variables. And both the abundance of the caterpillars and the timing had an effect on woodpecker productivity. It's quite a small effect, so it's highly significant because the sample size is so small, but it varies by about one chick from having virtually no caterpillars around to having massive defoliation. And pleasingly, it does seem that when the birds are synchronized, they can do better. So these are partial plots where you keep, one variable fixed where you plot the other. So in combination, a warm spring with a big mismatch and low caterpillars will have an adverse, quite a big adverse effect, even on great spotted woodpeckers. And so what I've done here is just to show you how big an effect this could be. So by combining those changes in the caterpillar peak and the nesting with temperature, you can put a line of what the mismatch between the food and the young is likely to be in different springs. And so down here, there's a big mismatch. And if the spring temperature was about average about 9, there'd be a good match. And then up here, the birds are much earlier than the caterpillars. And I've just stuck down on here the temperatures, the spring temperatures in the 80s, where we started the woodpecker study, compared with the 2010s. And you can see the effect that, although this is variable, on average, the birds were pretty matched with the caterpillars. Come to 2010s, and okay, half of the years are okay, but this lot up here are way mismatched. So these are the warm springs, and this is when the birds and the caterpillars are mismatched by 10 days or so. So big effect. So the birds are not responding to the warmer springs. And so we will start to see an effect on that. So we're thinking about this and say, well, why don't they respond? You know, they could nest earlier, couldn't they? Just get food and nest earlier. And a lot of it, I think, is to do with signals, temperature signals, and the time that the birds take to actually get up and breeding, whereas the caterpillars can respond very quickly. We decided to do a supplementary feeding experiment. And what we did is in one of the woods, Wormley Wood, put a metaphorical line down the middle of the wood, and one half provided fat blocks on a grid, 200-meter grid with feeders on the grid, and the other side we didn't provide any food whatsoever. So this was an experiment to look at the effect of supplementary feeding, and we didn't restrict which birds could use the food. We thought there's not going to be much mileage in trying to keep all the other birds out and only let the woodpeckers in. So the woodpeckers had to take their chance with the other species, and we topped up the food every few days, and we weighed how much food was taken. And then at the end of the feeding period, the birds went into their breeding season, and we measured the breeding success of the birds within the supplementary fed area compared with those outside. So really quite a well-designed experiment, really, I say so myself. And here are the results, which are really interesting. So what we got here with the open symbols is the fat consumption, how much fat is being used in these feeders. So we started at the end of January, early February, and topping up. And then as we come into May and June, the amount of fat taken fell right off. So this happened, the fat was there, it was available to the birds, but they weren't taking it. We had the frass trays in operation in the woods, and so the caterpillars actually arrived here. So you could see that the birds were not using the supplementary food when natural food was available in the form of the caterpillars. It was a bit expensive in the end. We didn't realize when we started how expensive it would be. But with this rate of fat consumption, every time we were changing it, I was having to carry about 10 kilos of fat blocks into the wood to keep it going. Anyway, we managed that. And so we monitored the breeding success of the birds and what they did. And what we found was that the birds in the area with the supplementary food laid their eggs about 5 days earlier than the ones in the unfed ones. Now, it just happened that 2011, when we did this experiment, was one of the warmest springs on record. So that you can see here the caterpillar peak is very narrow and very early. And so this would have been a year when the birds were very adversely affected by mismatch. But what happened was both the fed and unfed birds laid about the same number of eggs, but the young fledged from the nests with supplementary feeding were about twice the unfed ones. And so this supplementary food to shift the laying date, and maybe they took a bit of supplementary food while they were nesting as well, actually made a massive difference to the breeding success of these birds. So that's gets me to the end of what I'm going to be saying about great spots, and I think it's worth reviewing why they've increased. So I'm quite a believer in trying to explain why things increase as well as why they decrease. Inevitably, in ornithology and particularly conservation science, you're concerned with things that are declining, so we're trying to explain declines, but we really ought to be able to explain why things are increasing as well. Why shouldn't we? And so for the great spot, I'm pretty sure that their heavy and frequent use of garden feeders is a factor in their population increase. We found from colouring birds in our Hertfordshire woods that the woodpeckers can go quite a way to feeders. So, you know, I think that is a factor. We showed clearly that the demise of the starling was actually to the benefit of the great spotted woodpecker, so they then started to do very well. And the thing on the bottom there that you're going to have to take my word for, because I don't have time to go into it, but actually, in spite of what you hear said frequently, the dead wood resources in our woods, and particularly our mature woods, has been going up and up and up. And we have the data for the Hertfordshire woods to show it. And we also have it from a national survey, a big one we did with the BTO and Rspb 2003, showing that dead wood, and particularly in lowland deciduous woods, has been increasing a lot. And it's the sort of dead wood that Great Spotted Woodpeckers favour. So that's the factor as well. And what that's about is there is no market now for woodland products in the UK. There's very little incentive for broadleaf woodlands to be managed. Right, motoring on. The lesser spot. Two pictures here. The first one, very good idea of the sort of foraging they do, and the one on the right there is a drumming bird. So they drum just like great spots. The drumming is rather different. Very soft, very long drum, so it can be told apart. But these birds are a real challenge to study in the UK. The numbers are now so low. They appear to be quite undemonstrative now, compared with how they would have been. And so it's been a real challenge. That's just a very quick reminder of where they are and the populations. I don't think I need to say much more about that. So the Rspb did a study because the lesser spot was red listed. And the main thing that came out of that study was incredibly low breeding success in UK compared with other European studies. And this slide just pulls together the data that were available at the time. So the best studies of all of lesser spotted woodpeckers that have ever been done were done by Ola Olsson and Ulf Wicklander in Sweden. They were very brave guys. They're now well into their middle age and got senior positions, but in the 90s, they actually took on doing PhDs on lesser spotted woodpecker, and it took them 10 years each to get the PhDs. But they got phenomenal data. But the key thing there is, overall their data, loads of nests. The lesser spots were producing about 3.5 young per nest. And there's a study in Germany with Eva Rosmanith and Kirsten Honch, and they got slightly lower breeding success. And then David Glue actually did an analysis of the BTO nest record cards up to the end of the 80s. And what data he got was saying that the lesser spots were producing about 3.5 young. And then along came my limited data from the Hertfordshire woods and the Rspb studies, which again is quite limited data, only 27 nests, with phenomenally low breeding success. And so we came out of those studies saying, well, almost certainly it's going to be low breeding success that is driving the decline of the lesser spot. The Rspb worked on lesser spots for about 5 years, all told. But to do studies on lesser spots with paid staff really didn't work, because the number of birds and nests that you could find were so low that it just turned into such an expensive operation. And so that work stopped. So we kind of left saying, well, we think it's low breeding success. Let's carry on. So that's where Woodpecker Network came in. So in 2015 with Linda, we started Woodpecker Network. We make no apologies for the fact that we copied Pied Fly Net, which was Malcolm Burgess's set up in Devon to coordinate the monitoring of pied flycatchers. We thought, yeah, we could do this for woodpeckers and lesser spots. So the objectives would encourage woodpecker studies, especially lesser spots, collect data on breeding successes on a wide scale, and make sure the data gets submitted to the BTNS record scheme and also the rare breeding bird panel. What the proposal was that we would actually lend people these nest cameras so that they could monitor their nests and get really good information on number of eggs, number of young and things. So this is the impact we had. So this graph here is the number of nests submitted to the BTO Nest record scheme from 1983 through to now. And it bumbled along at 5 or 6 per year. And there was a big peak in 2007 which was when Rspb paid people to go and find some nests, so they submitted quite a lot. I think they must have submitted a few nests for different years, because it seems a high peak. But the red bars there are the nests that have been submitted as a result of our Woodpecker Network. So we've now been averaging about 15 nests a year. And this is a big challenge, a tribute to the volunteers who are doing it, really, because this species is really challenging. And were the nests? Well, here's a map slightly out of date now, but essentially we are covering the existing range of the Lesser Spotted Woodpecker in the UK, the South East, the Welsh Marches, Nottinghamshire, South Yorkshire, and most nests, about 5 a year, are coming from the New Forest. And there is no doubt that now the New Forest is the best place to find Lesser Spotted Woodpeckers in the UK. It has lots of lesser spots, but also has the advantage of open access. So you can go virtually anywhere in the forest, which makes it very easy to follow birds. If woodpeckers are nesting in areas of private land, it becomes really tricky. So we use the cameras to monitor nests. Here's a really easy nest. This is a New Forest. This is a dead holly. There's a nest there. Had 3 or 4 young, which sadly actually got predated by a great spot. So it does happen, but we'll come on a bit more on that in a minute. And here's the inside of lesser spot nests. The wood chips are much smaller than great spot. So if you find wood chips on the ground under a dead tree in spring, have a look at the size. The lesser spots are much, much smaller. So the young hatch, they're just on the bare bottom of the nest. They lean on each other to stay warm. It does seem to be quite a problem maintaining the body temperature. And then after 10 days or so, the feathers start to appear and they don't have to be so much brooded. Right, so one thing we did, which was published last year, is I got all the data from our Woodpecker Network and all the BTO nest record data, and analyze the overall breeding success of Lesser Spotted Woodpecker from the 1940s through to now. And this is a plot of the first egg date of the lesser spot, so it's very variable, but it is becoming earlier. And so a simple regression through that, which you could put through those data points fine, and it would be statistically significant as that general decline. But actually, when you look at it, there's actually a break in that relationship. And up till about 1980, there wasn't really much trend in first egg date. But then after that, it came down. In fact, that graph for the 2 sections is a better fit to the data than the linear trend. I'd never seen that before. That's kind of suggesting that the warmer springs really did start to kick off in about 1980. The red line on that graph there is the equivalent line for the Great Spotted Woodpecker. Again, the same sort of trend. But the big thing to look at there is that there's about a 5-day difference. When I first saw this, I thought, that's a clue to what's happened to lesser spots. They're being outcompeted and they can only nest late, and so there's no food for them. But actually, it turns out when you look at it, that lesser spots have always nested 5 days later. That seems to be their adaptation. And when you look in detail, you find that that's actually the case everywhere. And so Thomas Wesolowski, who sadly died only a few months ago, but was a great woodpecker man in Białowieża Forest in Poland, published a paper recently where he looked at the nesting seasons of all the woodpecker species there. And the 2 late nesting woodpeckers were the lesser spot and the 3-toed. So lesser spot has always nested late, and it's adapted to do that. And one of the challenges is to understand why, because that could be a clue to what's going on. So we looked at whether the clutch size had changed over time, and the data are pretty limited, particularly in the early years, but there's no evidence really. It could be but on the data we've got, it hasn't really changed. It's 5.5 always. The thing that has significantly changed over time is the number of young fledged. And here's a graph, and it's gone down from 4 to 2. And so it's not quite as low as those Rspb studies that I showed you in the Hertfordshire data. So it's about 2 rather than 1.5, but it's still very low now, much lower than it used to be. And this includes all data, includes successful and failed nests. And so you could say, oh, well, that's because the nests have been predated, and that's why the average number of young is much lower. But it's not the case, really. The rate of the nest survival rates, these Mayfield nest survivals, haven't changed. So what I've done here is actually divide the data into pre-1980, when Lesser Spot was doing well, increasing, 1980 to 99, and 2000 to now. And these are the nest survivals in those 3 different periods during incubation and chick rearing. So there's a hint that the nest survival was a bit lower in chick rearing now, but that's not statistically significant at all. And so if the suggestion is that it's Great Spotted Woodpecker nest predation that's causing the low breeding success of lesser spots, then it just doesn't stand up. And of these nest failures, maybe only about 1/3 of them can be attributed to great spots. So all sorts of other things happen as well. And this table kind of summarizes it really. So in Sweden, they actually found quite a lot of pairs that didn't actually lay any eggs in the season. So no eggs laid. So you can't really count that as a failure because they've not even started. But then they had desertion. There's all sorts of complications about the pairing and mating system of lesser spots, which leads some of them to desert, and predation, great spots and weasel. Germany, great spot and jay predation. Hertfordshire was great spot predation. Rspb study was desertion because of loss of adult and flooding. And I think one of the reasons was also very poor weather was actually driving the adult desertion with some great spots. Our Woodpecker Network data has nest predation for some of the failures, but cold weather and wet weather too. So great spot predation's there, but it's only one of the causes of failure, and it doesn't seem to have changed over time. So there's no evidence that this rapid increase in great spot populations has really increased the rate of nest predation. And the Rspb looked at this in considerable detail because it was one of the leading hypotheses for the lesser spot decline when we started. And so we looked at the presence of lesser spots versus great spot densities in the woods. We looked at the breeding success versus great spot density. We did timed observations on nests to look at interactions, because lots of aggressive interactions go on between the species. But none of those really came out with anything significant on great spots. The main cause of nest failure was this starvation and loss from adult. But having said that, some of the failures were due to great spots. I'm not saying great spots are innocent. All I'm saying is they're not the main driver of low breeding success. And this sums it up really. So what I've done here is pulled together the great spot breeding parameters and put them beside the lesser spot ones, fully updated with what we know now. And so they both lay about 5.5 eggs. That seems pretty good. That matches. The overall nest survival for great spots is 0.86. For lessers, it's a bit lower at 0.8, but still pretty high. The big difference is the number of young per successful nest. So in great spots, they managed to turn 5 eggs into 4 young, so they might lose 1 on the way. For lesser spots, invariably there's a lot of brood reduction goes on, and so 5 eggs turns into 1 or 2, 3 young. And that, when you look at it in terms of losses of potential productivity, that is the biggest problem for lesser spot, the difference between the number of eggs they lay and the number of young they get out from successful nests. So if you then factor in the failure rate of nests, so the overall young per nest drops a little bit for great spot, drops a bit more for lessers. But the big loss of potential is this loss of young. And that seems very much related to brood reduction. And we think from all our evidence, it mainly happens soon after hatching. And it could well be that this late nesting of lesser spots is actually an adaptation to have better conditions around the time that the young hatch, rather than the peak food demand of the young. So I think there's a problem for the adults in maintaining the temperature of those young. And we find all the time that you might have 5, 6 eggs in a lesser spot nest, and you see the young after only a few days, and it might be down to 2 or 3. So those young are definitely disappearing in the very early stages of their life. Another little thing that I found, I didn't discover this till a couple of years ago, but actually in the Netherlands, so this is pertinent to the thing as to whether it's great spots causing a decline of lesser spots. In the Netherlands, both great spot and lesser spot are increasing. So these are the graphs that come from Sovon, and the maps at the bottom are the Sovon Atlas maps. And just like the UK, the two species actually have similar distributions. Lesser spot's obviously much less dense than great spot, but they're in the same sort of places. Exactly what we're finding in the UK. The places where lesser spots are really declining big time are actually not the places that have the highest densities of great spots. And that fits with what the Rspb studies were saying as well. So that's where we are in terms of the causes of decline. I'm now pretty certain, we're both pretty certain, it's this low breeding success that is the issue. But then the next question is, well, why? What's going on? And we're looking at two things now in terms of what next. The first is the early season, what it is that lets the birds get going with nesting. So we showed for great spots that actually if you gave them extra food, they'd nest earlier. For lesser spots, Oliver Olsen and Ulf Wicklander found that in years when there were what they called good years for this micromoth, Argyresia godartella, I never know how to pronounce it, the lesser spots did really well. They nested early and had very high nesting success, suggesting that there was actually a constraint on them early on in terms of food. And the life cycle of this little micromoth is amazing. So they lay their eggs in the flowers of birch and alder in the summer of one season, and the eggs hatch and their caterpillars munch away inside the catkins over winter. And then they emerge from the catkins in early spring before the catkins fully open and go marching off down the tree and pupate under the bark and then emerge as adult moths in the summer. So you can see how that's available. And this could be an explanation of why one thing we have found is that lesser spots are very much associated with wet woodland with birch and alder. And everybody leaps to the conclusion it's dead wood. Well, maybe, but it could also be this this micromoth. And it's a very widespread moth in the UK as well. So we've been doing some collecting of catkins. So we thought we were mad collecting caterpillar poo, but now we're into catkins. And we've actually found that up to 20% of birch catkins have little emergence holes in them from these moth caterpillars. So what we don't know at the moment is what drives this. Is it birch in particular locations? Does the birch need to be in the sun? Is it something like that? What age of the birch? That's what we're looking at. But it could also help to explain another thing we found is that lesser spot territories are often on the edges of things, or on the edges of woodland. Is that where there's the birch? The other interesting twist to this is that Jack Shutt, who did the microsatellite DNA work on the diets for the blue tits. It was talked about in the last talk. The most abundant invertebrate that he found his blue tits were taking in early spring was this moth, way above everything else, kind of matched the peanuts as well. So really, I think this caterpillar is probably important for quite a lot of birds. And as bird watchers, we often see small birds playing around in birch trees in early spring. So this could be what's going on. Right, at the other end of the scale, we need to look at the nestling diet and what's going on. So I talked a lot about the caterpillars. It turns out for the lesser spots, they are missing the caterpillar peak even more than great spots. And this has been well spotted already. So Eva Rosmanith in Germany produced this graph. I'm sorry for the quality of it. I nicked it off the website because I didn't want to pay 20 quid for a copy of the paper from the publisher. But what they've plotted here is the relative contribution to the diet of lesser spots of caterpillars, black things, and aphids. And what happens somewhere around hatching time, there's a switch, and the birds actually switch to aphids as the caterpillars run out. And you can see how this could be really quite sensitive. And here's a Mike Reed picture at the top here, beautiful picture, showing a New Forest lesser spot bringing prey to the nest. And this is actually a mixture. It's got a couple of caterpillars in, but beakfuls of aphids. And I think they ought to rename the lesser spot the aphid woodpecker, really, because they do seem so dependent on it. And by chance, we recently published a paper in British Birds on lesser spot population estimates. And the editor selected a picture for the cover, and it was taken in Poland, and it was taken in May. And here's a lesser spot with a beak full of aphids, collecting aphids off this tree. I haven't yet worked out what the species is, but it's clearly feeding its young on aphids. And we really do need to understand this a bit better in this switch. And it could well be that this switch is highly sensitive to warmer springs and climate change. And the final what's next, a couple of things. So first in the bottom is, I'm sure you've all noticed that the ash trees are all dying. And ash has a bark beetle as well as elm had a bark beetle. And in fact, around us in Sussex on the Downs, the ash is really going and gone very quickly. And we found that the bark beetles are all over the ash. Loads of galleries like this. These are the galleries of the larvae of the bark beetle. And we've had lots of instances of great spotted woodpeckers foraging on the larvae. And so one question is, well, will lesser spots benefit from the ash dying in the way they did benefit from the elm disease? And the final one there is the lesser spot on the garden feeder. They're not recorded that often on garden feeders, but we have more and more anecdotal evidence that some of our birds where we're getting records are using garden feeders. And we have one site in Norfolk where it's very regular, the birds do very well, where supplementary food has been provided, and it does seem to help them. But what we're planning to do next year with Rspb on some of their reserves is actually to set up some feeders in places where we think lesser spots might find them, and to actually monitor them to see A, whether lesser spots find them, and then B, whether it actually makes any difference to the nest timing and breeding success the way it did for great spots. Now, I'm not suggesting in any sense that this is a solution for the lesser spot, but it's a way of actually learning a bit more about the early season constraints that they might be under and what might be driving things. I think that's me. So in the summary is that lesser spot, I think, are declining because of low breeding success. I think the low breeding success is related to their diet and the timing of nesting, and probably to the habitat that they find themselves in the woodland management. And that great spot is not the main driver, but great spot predation doesn't help. about a third of the predation events are great spots. So they won't be helping, but they're not the prime cause. So that's me. If anybody is interested in those papers, contact us on that website. And last but by no means least, have to thank all the volunteers. So all the lesser spot data came from volunteer effort. It's fantastic. You really do have to be dedicated to study lesser spotted woodpeckers because they are pretty tricky birds. So thanks very much.
Thank you.
Thanks very much indeed, Ken.
Yeah.
Can you hear me all right?
Yes.
Good. Okay. Are you happy to take a few questions?
If there are any, yep.
Well, I can start off with one or two.
I'm a bit in the dark here because you don't see the people or the questions. So
No, well, I've picked up on one or two. And one of them is something I was going to ask anyway. Do you see the lesser spotted woodpecker going functionally extinct in the UK in the medium future? And as a corollary, can you explain a bit more about why there should be the difference in trends between the UK and the Netherlands?
sorry, Linda's talking to me as well.
Just unshare your screen.
I've got to unshare my screen apparently. Do I see them going functionally extinct?
Yeah.
I'm trying to be optimistic. I think they might end up with a different distribution. I'm a bit nervous about the southeast, but I think they could still remain there. And what was the second question?
And why the difference in trends between the Netherlands and the UK in lesser spotted woodpeckers?
That's a good question. I plan to go and have a look. I could think of lots of possibles. I think one reason is that a lot of their woodlands are likely to be wet, much wetter than ours because the way the Netherlands is. I think they have a lot of new woodlands, far more new woodlands than we have, and a lot of edge. And I think when you look at some of the data they have on the other species, even though the Netherlands is quite close to us, it has a much more continental climate. And I don't think has seen the same level of spring warming that we've had here. Yeah, we do seem to be suffering from having very warm conditions now.
Because it is very striking indeed, the difference that you documented.
Yeah, amazing.
And there's a question up now. Where do you see the hope for the lesser spotted woodpecker in the UK?
Getting the habitat management right, really. So lots of new woodlands created might, if we do the right things, could help. The problem at the moment is that we keep saying to people that we're not producing enough of them. So I wouldn't be at all surprised if they could do quite well in Scotland if there were ever enough of them to get there. And I think we've already put out feelers to saying, well, maybe we should start to think about taking some into captivity and trying to release them further north in Scotland where there's far more birch and the springs are a bit later. They don't have any problem with winter conditions. So in Sweden, where it was really pretty cold conditions, and most of the annual mortality was actually during the breeding season, not during the winter. So they don't have a problem with cold.
Right. So, yes, quite complicated altogether, lesser spotted woodpeckers.
Well, these things often are, I think.
Someone's asking now, is there a fossil record for lesser spotted ever colonising Scotland?
I don't know. I really don't know.
I would rather doubt there's much of a fossil record for any lesser spotted woodpeckers anywhere myself, but there we go.
I think it's easy to say I don't know.
Switching to a different question that right from the start of your talk, is it clear that the colonisation of Ireland by great spotted woodpeckers was a natural event?
You'd have to be a pretty determined conspiracy theorist
No, I'm not one myself. I was just asking.
Yeah, I think it was. It happened in more than one place.
Right.
There was a proposal to introduce them to Ireland, which was bumbling along and getting a bit of traction. And quite a few of us were trying to stop that happening. And before it got any further, they arrived on their own. So I'm pretty sure they just got there on their own. You know, we all write about great spotted woodpeckers being highly sedentary. So the ringing recoveries kind of suggest that, because they're all within about 5 kilometres, and I've written it myself all over the place that they're sedentary. We had a bit of a shock a few years ago. Some of you may have noticed a little note about it, where one of our colouring breeding great spotted woodpeckers from Hertfordshire turned up on a bird feeder in Northamptonshire, almost exactly 100 kilometres to the north in January. And we thought that was remarkable. Oh, well, anyway, we got a phone call the next winter and the bird was on the same feeder in Northamptonshire again. We'd failed to find it in Hertfordshire in the intervening breeding season, so I assumed it just decided to migrate and stay in Northamptonshire. But the next breeding season, it was back in the Hertfordshire wood. So that's a bird that was moving, I think, 100 kilometres between breeding and wintering area. And it also fits with a whole load of colouring of birds we did in these woods in winter and didn't see them again breeding. So I think there's more movement going on with great spots than we imagine. And the speed at which they've marched up through Scotland suggests that as well.
No, it requires a very limited number of birds to make long distance movements for it to become very important. And the tie-in with the colonisation of Ireland with the increasing great spotted woodpecker population is what you might expect.
Yeah, so you could never prove it conclusively, but I think it's pretty clear. And anyway, there used to always be some great spots in Ireland every winter from continental birds. And so there was all the migration from Scandinavia over to Scotland and a few overshot into Ireland. And over all the years, none of those ever stayed to breed.
Does anybody else have a question they wish to pose directly? I think I've picked up on the ones I've noticed on chat.
Yeah, talking about Northamptonshire, can you hear me?
Yep.
I put a quote in the chat from Lord Lilford in 1895, where, like the examples you gave earlier on in the talk of other counties, lesser spotted woodpecker was more common than the great spotted woodpecker. But he also says now they're more common, which suggests that perhaps they were less common before then. So is there any other, have you come across evidence of change in population?
No, I haven't. That's interesting. So I did promise to say something about that. So I suspect that in those days, the woodlands were much more heavily managed and you had a much bigger fraction of young woodland and you didn't have the sort of habitat that favoured great spots. And we obviously didn't have garden feeding and all that stuff. So I think that's probably why lesser spots were more common. And you do see records of them being considered to be vermin by the gamekeepers, great spots. So maybe the gamekeepers nobbled them as well. But it is interesting, and it's all over the place. You look at county avifaunas.
Right, thank you.
Hi, Ken, I've got a question.
Hey, Nick.
How are you? Do you think there's any correlation between what appears to be increasing tit numbers of various different species and cavity competition? I noticed a few years ago you had a marsh tit, I think it was. Someone recorded a marsh tit on Lesser Spot Network that booted out a lesser spot. I wonder if you've come across that. We haven't at our site, but they obviously the old holes are used.
Yeah. So yes, it does happen. We had the marsh tit where it was very well observed. and we've had a few cases of blue tip as well. And I suspect that there's a whole choreography going on between all these different competing species in early spring.
Yeah.
Who's going to end up where?
Yeah.
And this year, for instance, we had loads of cases where we thought we'd pinned down lesser spots, but then they never used the cavity.
I had exactly the same this year. That's what I was asking this year. And I had 3 nicely drilled out cavities, never used.
Yep. We had a day in Surrey, went round 2, and both the same, and they weren't used by anything, not, you know.
Yeah.
And those were the sort of things that Ulf Wictander was finding in Sweden. We've not seen it until this year. It seemed to be the very cold spring, where I guess if you're a bird making your own cavity, there's a premium on making it and getting on nesting quickly.
Yeah.
And the longer the cavity is sitting around, the more chance there is of a predator finding it. And so they'll try and, you know, make a cavity and use it straight away. And that's what we think the lesser spots were doing. So I think that could happen. I think there could be second order effects in that it's possible that the lesser spots end up nesting later because they've lost out in this competitive process early on. But that's all I think, really.
Yeah.
You know, talking about the aphids, I think, you know, in your Herefordshire orchards, I suspect aphids might be a key thing.
Yeah, I'd expect so. I need to send you a load of the pictures of the previous year's food, you know, just so you can compare that against it. But aphids and bark lice, you know, the tiny little black gnats seem to, the grey coloured ones seem to be very prevalent during feeding. And I'm not monitoring those to see how they're doing.
So we asked photographers, and I got quite a reasonable response, but we could get more for really good photos of lesser spots bringing food to the nest.
Yeah.
With dates and what we now know about timing of caterpillars. So we've got such good data now on temperature and timing of caterpillars, we can really say where they, you know, when they'll be around anywhere in any year.
Yeah.
We could look at that and see what the lesser spots are doing.
Yeah. Yeah, so it seems like the competition between smaller birds has probably always been there and might not be contributing, because there's a lot of talk about increasing winter tit survival, and
it's not helping.
No.
But I don't think it's the main driver. I think it's the fundamental ecology of the lesser spot that's the driver.
Yeah. Cheers.
Any more questions? Or?
Yeah, I've got a good question. Have you seen any regional differences in the survival of clutches? So I know you said the New Forest is quite a hot spot for the species. Is there any data to suggest that in the New Forest, chicks are surviving more than other areas, or is there not enough data to show that?
Right. So the only thing I've looked at is the New Forest compared with the rest. So we don't have enough data from all the others really to do that yet. And the reason I was looking at it was I was starting to think about if low breeding success is the problem, then if we want the birds to survive in the New Forest, we'd hope they'd have higher breeding success. Yeah. And so far they haven't. They've got the same breeding success as everywhere else. There's no statistical difference, which is a bit depressing, really, because it could mean that actually the New Forest it's got lots at the moment, but within the next few decades they might start to thin out. So yeah, that's all I've done on it, really.
Okay, thank you.
Ken, it's Gerard here. Am I allowed to butt in from Budapest here? I don't quite know what the etiquette is here.
You sound all right.
Okay. I don't feel very well, but never mind.
It's good to hear from you anyway.
A couple of things. I've got about 1,000 questions now, but first of all, you know, we met in Poland and you've been around Europe a little bit, and I'm here in Central Europe. We don't have exact data on lesser spotted population trends in Hungary, but predation, which was the main thing you were just talking about. We don't see any evidence at all that great spots or even Syrian woodpecker and even wryneck, which also predate other cavity nesting birds, we don't see at all that these species impact lesser spots at all. We just don't see that. In fact, you mentioned Holland, where both species are actually increasing at the same time. It's probably stable, I would say, the lesser spot population here. Great spot is probably increasing. Syrian is probably, which is another predator, if you like, another woodpecker predator. So just want to say I'm very happy that you came to the same conclusions that I suspected, because I quite often get letters or inquiries from people saying, from England usually, saying that the local marsh tit or willow tit or some cavity nesting bird was predated by a naughty great spotted woodpecker, and what should we do about it? And so I'm rambling on here, but I think the main point for me is that when you get to a low number of birds, like lesser spots in Britain, when you get to then these factors kick in, don't they? Predation, nest site competition. But when you have, let's say, a healthy, whatever that means, healthy number of lesser spots or anything else, then those factors are not significant. That's my view on it. I don't know.
You probably won't have spotted in Hungary, but there's been a big debate over here, following Alex Lee's and Jack Schutt's paper on supplementary feeding about it. So it's been very much in the news in the last couple of months, which is probably why you've had all the inquiries.
Mm-hmm.
I think the population that Ross Smith and the other German lady were studying in Germany was declining. But I don't think in general they are. I suspect in Britain a lot of the issue is a landscape one, and the landscapes they've disappeared from are actually now not very woodpecker friendly. So I was brought up in Oxfordshire, which had masses of hedgerow elms before Dutch elm disease, and if you stood back and looked at Oxfordshire from a distance, it would look like a wooded county. You go and stand back and look at Oxfordshire from a distance now, and there are no hedgerow trees. And so the lesser spot liking edges, when they used to use hedgerow trees and stuff, they've probably just completely lost the habitat there now. And on top of that, you've probably got farming either side of the hedgerow, meaning there's less in terms of invertebrate resources for them. So I think that's a big factor, probably why they've gone from lots of bits of East Anglia and lots of areas with low levels of woodland cover.
Ken, we've had a huge amount of discussion, and I think probably the time has come when we're going to have to draw the meeting to a close. I would like to thank you very much for an extremely stimulating talk, which I'm sure the audience in general will have much appreciated. And I'd like to hand over to Chris just to close the meeting, if I may.
Thanks, Robert.
And may I just echo what Robert said? I think we could go on for a long time, but I'm afraid we must now go and get something to eat, I think. And thank you very much, Ken. It's been a tremendous talk and absolutely engrossing and an extremely interesting range of questions. So thank you, and thank everybody else. And may we just say a round of applause for Ken.